Good afternoon, everyone. My name is Jilayu. Today, I would like to present the jumping hoops. I will talk about the problems, observation, terms and definitions, theory, and the last is summarize. This is my observation. The hoop jumps into the air when I press the surface for the hoops. And the problem say an elastic hoops is placed against a hard surface and then suddenly released. The hoop can jump high in the air. Investigate how the height of the jump depends on the relevant parameters. I define an elastic hoop is wire and bend it to a circular hoop for this picture. And I define a height of the jumping is the height of the center of mass from the initial point to center of mass at the peak point. And the relevant parameters. I change the hoop's diameter. I change the hoop thickness and I change the distance delta from the equilibrium point to the point where the force were applied in this picture. Delta. This picture, I measure a force when I press the hoop in distance delta. The graph shows that in the red line is obey a Hooke's law and slope of this line is spin constant and in my experiment I will call hoops constant. Compare hoops constant and thickness. When I increase the thickness, the hoops constant will be increased too. And compare the hoops constant with diameter. When I increase the diameter, the hoops constant will be decreased. And before I talk about the Hooke's law, and I will use the Hooke's law to a simple model, and I will show you that at the peak point, hoop had a strain energy transfer to a gravitational energy only. These are my simple models. At the initial point, the total energy has the strain energy for the hoops, and at the peak point, the total energy has the gravitational energy. I have two equations and I solve equation and tell you that the height at the peak point direct proportional to the hoop constant. This compare the hoop constant and the height from my experiment. You see that when the hoop constant increase, the height will be increased too. And compare the hoop constant when the delta or distance from the equilibrium point to the point that were force applied increase, the height will be increased too. Conclusion: when the hoop constant increase, the height will be increased too. And hoop constant depend on the the thickness and the diameter. And the second is the height of jumping hoof when the delta or distance from the equilibrium point to the point that force apply increase, the height will be increased too. Now I will compare the height for my experiment and the theory. You see that blue is a theory and red is my experiment. You see that it's different between this point to that point. It means that my simple model is a good model, and I will change my model to an advanced model. My advanced model, I consider energy in system consists of strain energy, kinetic energy, gravitational energy, vibrational energy, and energy lost to flow and air drags. And energy that show this is an energy endpoint, but the term in energy maybe in some term maybe zero in time, in different time, such as when the hoof in the air, the term is strain energy will be zero, and that's the air drag effect for hoof's motion. You see that this horizontal is time and the vertical is the height. I measure from the center of mass. When I calculate the second derivative of the height, it shows that this is an acceleration from the center of mass. This is near close to the gravitational acceleration, and I can conclude that the air drag can be negligible. And the total energy at the initial point when I press the force to this is a strain energy, and when the hoof lifts off the floor, this term is neglect, and this term is the gravitational energy, and this term is kinetic energy, and this term is the losing to the floor, energy lost to the floor, and this term is strain energy when it lifts off. When hoof lift off, I consider the new total energy and neglect the energy lost to the floor. This is the new total energy, and I will calculate the energy at the peak point. At the peak point, it had a gravitational energy and vibrational energy. And I solve this equation and tell you that when the energy of vibration decrease, the height will be increased. And from this equation, I measure this term and its parameter m v0 or phi and delta, and I will add in an equation and solve the equation. Is show that when the height increase, the energy of vibration decrease. For my conclusion, the height of jumping hoops increased as its energy of vibration decreases. And I still summarize when I talk before. When the hoof constant increase, the height will be increased too. But the hoof constant depend on thickness and the diameter. And when I force the surface hoof in distance delta, when the delta increase, the peak height will be increased too. And the last, when the energy of vibration decrease, the height will be increased too. Thank you.
Okay, please go back to your experimental setup.
Experimental. What is slide number? Can you?
I can't remember. Slide. 11, yeah. Well, you say that your height, the height for calculation, you set from the center of mass.
Yes.
How can you measure or set up that center of mass?
Now you look this picture. This is a center of mass, and when I force the surface hoof, I record this video, and I use tracker to track this point and find the center of mass from this function in the tracker. Yes.
Okay. Okay, please go to slide that about all of the energy equation.
All of the simple or advanced?
Advanced.
Advanced. Sorry.
The total of the equation.
Total of equation. Wait. Yes, right?
Okay, you cut EA out.
Yes.
Sorry, what EA stand for?
And energy loss to the air drags.
Why you cut it off?
Because when you see this graph, I will show you that the air drag can be negligible for my hoof's motion because the acceleration from the center of mass near close to the gravitational acceleration, and I can be neglect the air drags.
Okay. And go back to the equation. At the highest point, well, at the highest point, there is still a vibration.
Yes.
And do you think that is there any kind of the elastic energy that still storage in that hoops? Because the elastic energy, the storage, is caused from the movement that the object blend itself. So is that any types of that energy to be at the energy loss?
Yes. I use this term to define the energy at the peak point. This term, and this term I don't know is depend on this other parameter, and I know this is a number, and I find it from the equation.
Okay, so you say that the elastic energy, the storage on the highest point is not really important, or there is no that energy on the highest point?
Again, please.
Okay, I say that at the highest point,
Yes.
there is still a vibrating.
Yes, vibrating.
Yeah, and when it vibrating, the shape of these hoops is changing.
Change.
Yes.
Yes.
And there will be some kind of the energies occur. That is the energy that storage and cause from changing of the shape. If there is something changing of the shape, is that maybe still the elastic energy that still be storage on the highest point?
The strain energy I consider when it's on the floor and it lift off, and in the air I didn't
You-
consider it
Okay, you
because I consider in the energy of vibration.
Okay, if you say that there is a resistance of the air force when it go
Yes.
up, okay, if we see on the point wheel, we'll see that it will be a vibration. But if you see from the side wheel, do you think that the hoops is vibrate
Yes, the
in
hoop
this
vibrate.
direction?
Hoop vibrate.
No. If you see from the side wheel,
Yes.
because there is the air resistance.
Yes.
So is that any kind of the vibrate in this in this
Can
axis?
you show text the picture?
Okay. Okay, if we consider the hoops, this is for the side wheel.
Yes.
You see that like this.
Yes.
Okay, it's vibrating. But if you look in the side wheel, like this, you how to draw it. Side wheel like this. If you look in the side of the hoops, and because you say that there is the resistance of the air, do you think that it's moving in kind of, I don't know, this direction, out like this? How to explain it?
It's moved up.
Yeah, maybe I have get. Okay, I will use my watch as a hoops. Okay,
Okay.
when it get up, it vibrate like this,
Yes.
like this. But if you consider from this side, is there vibrate in this side?
No. It's
Okay,
it vibrates on this side.
only.
Yes, and direct and two
Oh.
direct. Yes.
Okay, and when you set up the experiment, okay, you know how high is it, and do you have any type of setup that you know that it in, I don't know, is how do you know that it's perpendicular in this side? I mean, how you set it?
Oh, I record this data many times and I choose the best one to analyze.
Oh, you choose the best one
Yes.
to analyze. Okay. Okay, from the parameters that you choose,
Parameter.
the parameter that you choose, is there any equation that support that why you choose these parameters?
Why I choose this parameter?
Yes, is there any equation that support this idea?
No, I don't have theory, but it is in my daily life.
So you just
I can
random
observe.
Observe and random it?
No, I don't random.
Okay, and for the hoops that you use is a round shape.
Yes, round shape.
Do you think that is there any effect if the round shape of the hoop change into the flat one, which have the difference between the thickness and the width? Do you think that if we change the hoops into that shape, will be anything different for the result?
Yes, I think it be different, but in my experience, the thickness is less than the diameter, and I can neglect this effect.
So that means you say that there is no effect between the ratio of that.
Yes, because you see thickness is 1 millimeter, and this one is, and diameter is 18 centimeter. It is more than too much, more than 18 is
Okay,
too much.
so okay. Move to the energy about the takeoff and the air drags.
Take off and air drag. What is number? This page, all right.
Takeoff
Take. All this.
22, maybe. Can you describe about the energies of the floor during takeoff?
Energy to the floor.
EF, yes.
Yes, it is energy lost to the floor.
Lost to the floor. How?
How?
With,
Because we lift off the floor acts to the surface of hoof and will lost the energy.
energy.
Yes, to the floor.
Okay, so move to your conclusion. Okay, the point that I summarize my idea is, the first, I asked him about set up the experiment about finding the center of mass. He answered me that he find the center of mass from the tracker, which I think sometimes there will be some kind of error if we don't set it. And I asked him about where he get these parameters, and he said that he get it from the observe. But in a point that the thickness and the width, I think that there will be some kind of effect happen from the round shape and the flat one. And this, okay, thank you.
Sorry, thank you. Why the air drag can be neglected by showing that the acceleration is similar to that of the Earth's gravity, and you have a good composition of your energy conservation equation. Your experiment setup is reliable because you use the letting go thing. I think it's more believable than using finger. And your data, you said you did it many times, which is good quality. But the thing that I wonder is about your vibration energy. You didn't mention about it, although you put it in your equation. And also the energy lost to the floor. And here again, the vibration, what does it depends on? And the elastic strain energy. What does this term mean? Okay. Now come to the opponent. You pointed out the strain energy at the peak because the reporter doesn't mention about that, and you pointed it out because you see that maybe perhaps there's some strain energy, and you have considered the direction of vibration energy. You consider the shape of the hoops, whether it's thickness and widthness, and you mention about the floor energy. Maybe that you lack is you didn't look at all energy, and I think that's all.
So, the reporter, could you please go to slide 21st?
21st.
You said that the height is depend on the constant K, right?
Yes.
Hoop constant. What happened there when the hoop constant going up, I mean something like from 10.9 to 11.44. But the height, why is going down?
Why it's going down?
Both from your theory and experiment. What happened there?
I think that because I change the diameter and the mass of hoof will change in this equation. This equation will change. Is this? And this is this equation related with the is the same hoof and change the delta and then height will be changed, but you compare with this and this picture, right? Because it's this different K and in this different mass, right? Because when I conclude, you see, this picture, I conclude that I choose the same delta, but change the hoof constant. Yes, but one delta. Yes. I do many times, and I choose the best one. Best of this. It had I use taker to record and data, and I track the center of mass at the highest point, the peak point. I record the height of peak point at the experiment, and I average it, and I add to the equation. Yes, average. Yes. Yes, just one.
If I noticed right there, the one in the middle with the hoop constant of 18.28, it seems like when you use different delta, you have a little bit, the spread is much more than, what happens at the hoop constant at 37 and at 11. Could you possibly explain what you see right there? The spread mean the difference in terms of the peak height. If you do at delta at 5 centimeter and delta at 3 centimeters.
5 centimeters.
The spread. The difference.
The grade and the groove for each of them are not the same. You can see that. Look at your plot.
Look at the one in the middle.
This.
The middle, 18.28 hoop constant right there. Yeah. Okay, look on the board. Right here, you see the spread.
Yes.
The spread much more than this, right?
Yes.
Could you possibly explain what happens right there?
I think that please wait. I just find my answer. Sorry, I don't describe. Sorry, I don't describe.
Okay. I would like to ask the opponent. You keep asking him about the elastic energy. What is your answer for that? What you expect?
What expect? I think there be some kind of it, a little bit of it.
Why? You mean
Because-
like when it at the peak?
At a peak, yes, because there is a vibration, and that is mean a changing of the shape. Well, in my opinion, the definition of the elastic energy is mean that it comes from bending the shape of it. So I think because of that vibration, it could be some kind of a little storage of the elastic energy.
Can I ask further question about this? The reporter has strain energy, vibrational energy. Are they different from your elastic energy? Strain, vibrational, and you have elastic. Are they different? How are they different?
I think that the first one of the strain energy is the total energy of the elastic. But for the elastic energy that I mentioned on the top point is mean some kind of, when it convert, is not all that is total of this of the elastic energy is a stress, but when it go to the top is there some kind of part that is not being converted into other energy.
Same question to the reviewer.
About elastic energy.
Yeah, about elastic energy at the peak point, and then it's still vibrating. So do you think that because the opponent expect that there should be a term for elastic energy, you agree with her or you agree with him that he didn't put that in there? Or you have another expectation?
I also agree with the opponent about the elastic energy because the reporter says when he pressed it, there is the strain energy, and that strain energy, it has a form, he mentioned like 1/2 K delta square, and it goes up. I think that strain energy, it is converted to other forms. Let's say at the peak, it is the MGH and vibration, and some is gone to the air drag. But I think maybe a portion of it is still left in it.
Okay, so this time I will ask all of you, so please listen. So let's go to slide 26. So I will ask the reporter first. Okay, this slide. So before I move to, I tell these two to prepare first. So there's something probably wrong with this equation. So you can try to figure it out and then go back. But now, reporter, so let me ask you this question. So I prepared this thing already. When you, I set up different, so let's say that I drop it like this, and now same height, but now I press it and then drop. Do you know, do you think the velocity of the center of mass when it hit the floor, will it be the same in both cases? First case is just no press, just drop it. Second
Same.
case,
I think the same.
yeah. So do you see anything wrong with this equation? I agree. So that what I
I didn't see it's wrong.
Okay, so opponent first. Do you see anything wrong with this equation?
Wait a minute. This equation.
By the way, maybe just I give more hint because you need not do this slide. V0 it just mean the velocity when it take off, right? Right? The report.
Right.
Yeah. Okay. Just give. So V0 mean the velocity when it take off from the floor. Any question from the any answer from the opponent?
Sorry, this equation is on the highest point or between the process of getting.
Big H is the highest point.
Is the highest point storage. How?
Okay, I think it's time's up. Anything wrong from the reviewer?
Is this the way down, right?
No, this is the way up.
This is the way up. MV0. I'm just not sure about the term K multiplied with delta minus H overall square.
Yeah, was anything wrong with that?
I don't know why it can be minus in that way.
Thank you.
Page number
12.
This graph, what are the differences between the red and the blue dots here?
The rest is obey Hooke's law and the
So
hoop,
with the same spring
yes, same hoops.
or same hoop.
Yes,
And what happened to the blue dots on the right side?
and is this that?
You press it more with
Yeah.
raise force.
Yes, and the hoops change the shape.
Okay, show me. For this one, for the red points, when you press it down with more forces, then delta is increases. And then what happened to the first blue dot?
It
It
bend.
bend like this,
No, it's sorry.
twist. Oh, so it twists. Delta increases, but F is less, become smaller. Okay. Okay. Okay, thank you all.